Okay, everybody. So this is pretty much the nacelle kit. This is going to be a big print right here. I printed mine at 20% infill, which I think is more than enough for strength.
Jeff from the future, these nacelles are going to look different. I ended up taking my Dremel and dremeling out a relief there. And if you look, I also dremeled out a relief there too. I had a piece of hot glue to hold that servo wire in place, and that's it. Your 3D printed copy will have this already made into it, so you don't have to Dremel or do anything like that. Also, your nacelle, this is still the original one. I brought this down lower, so that way you can grip onto this thing to get your prop nut on and off. This was just too tall, and that's it.
This took me about, and I printed it with a brim, I printed it with supports, I printed it in this orientation, and I think 20% is more than enough. If you printed this 100%, it's just more weight, and just from what I've learned flying, you want to keep the weight down. So this is one piece that you'll be printing. This is the nacelle, and then this is your motor cowling as well. I printed this piece at 50% infill. All of this is printed in PLA Plus by eSun. It's what I printed, everything that I printed in all my stuff. And I feel like it just works great. This nacelle is going to be made for this servo right here. This is an Emax ES3054. And I'll put that in there for you in just a moment. You're going to have to get this bearing kit. Comes with a pack of bearings. And then you're going to have to get this pin kit. Comes with a pack of pins.
It's Jeff from the future. Again, I'm using the same diameter pin. I just got a longer pin. That way I can push this thing all the way in when I'm done. And I got enough sticking out so I can, it just made it easier to work. So you can use a shorter pin, but I would just get the longer pin. Links in the description.
And then whatever motor and ESC you're going to use. The nacelle is designed to fit a 23, see if I can slide that in there one-handed, 2306 motor. Fits right in there, looks pretty trick. And when you get everything done, it is going to look like this. Not a whole lot to it, pretty simple. You're going to need some wiring extensions and everything. Servo extension for your servo. I got a whole bag of crap of leads and everything. Just going to solder everything up so I got plenty of room for the wires coming for the motor to that. The servo horn that comes with it is going to look like this square right here. You will have to take it, cut it down, and trim it to fit right there, and that's it. And of course you're going to need a prop. I'm going to try these 3-blade props because that's what drones use, so we're going to give it a shot. And that's it. And of course an ESC. So let me show you how this goes together, and we'll start there. Part about assembling this, and you can do this a couple different ways. What I typically do, what I would do is I'd probably grab your bearing. And this is going to be a press fit. And it's going to be a hard press fit because you don't want it to be loosey-goosey fit in there. So what I would do is you can put it on a, honestly you're going to want to put it on the ground, not the table. And I would just set it over and I would just force it in like so. So I'm going to take this, I'm going to go to the ground. You could put a pair of pliers in there if you can fit it. But just lining it up, lining this thing up, and then just pressing it in by just pushing on something like onto the ground, onto your floor, will do the trick. So I'm going to do that. And there you go. I pressed it in. As you're pressing in, you know, you can look from this angle, and then there you go. So, and then you want to make sure that's pretty flat. I might have to give that thing a little bit of a push, and that's it. And really, I mean, that's like, it's like the hard part. Next is the servo. when you do the servo, it comes with these little rubber isolators. And these do two things. These help you with the height of the servo sitting off of this. So if I can, I don't know if I can illustrate this, but if this right here is too low compared to this surface here, what you're going to find is that it will rub right here. It will rub. So you want to make sure that that piece is protruding up. I don't know if that made sense, but pretty much all you need to know is use the rubber isolators. If you get a little bit of binding, let's see here, where's my orientation? If you get a little bit of binding, like it's too tight, like these pieces are too close together, you can offset that very easily and just put a washer underneath this, just a thin 3mm washer, and I'll show you what one looks like here. And you can just use a little washer to just space that up. Again, this is all 3D printed. This isn't like a machined piece of aluminum. You're gonna have to do a little bit of sanding, a little bit of fine tuning, and that's how it's gonna work. So now what we're gonna do is we're gonna feed the servo into the little holder. There. There we go. And voila, there you go. You've assembled it. You can use your screws. You have to be careful. This top screw right here, it will protrude. It'll stick out just a tiny little smidge right there. So you can do a couple things. You don't have to use that screw. You can grab a different screw from like a hardware store. These are just sheet metal screws. And you can find one that's just a coon's hair shorter, like that one right there, which won't stick out, or you just put it in there. Whatever you want to do. I'll tell you what I'm going to do. I think I am just going to go for it. And actually, you know what I think I'm going to do? I take that back. I'm just going to use a washer. And then we'll go ahead and run this in. And there you go. Voila. Now, this part is just to kind of show you how everything works. And then this wiring will run through here. And you just gotta find the hole, as they say. And there you go. And again, this protrusion of your servo gear, if it's too low, you just come in and you add a washer right there to space that up. The next thing is the pin. Now this is kind of the tricky part. There's two things there's one thing that you do not want to do, and it's just how this assembles. Lift that over. This pin is going to be a press fit into this housing as well. As you see on my finished one, I always leave a little bit of that nub sticking out, and that is so that I can remove the pin. If you push this thing in flat, I don't know, you're going to see here just how this goes on. I don't know how you're going to, it's almost going to be stuck because you almost have to pull this pin out to get the nacelle off. So, just a design flaw, I guess. I don't know. It is what it is. That's all I can say. You know, if you wanted to, you could definitely get a, now that I'm thinking about this, just grab a longer pin, and that would ensure that you always have some sticking out. That way you can get on it with a pair of vice grips, so on and so forth. This is going to be another one of those things where you're going to have to put it on the ground, use a piece of, use some pliers to press this in. And I'm going to try to do that right now. And there you go. I was able to do it to push it in. It's a pain in the butt, but once you do it, life will be good. And then you can just kind of squeeze it in. Alrighty, so I've squeezed it in. It's pretty flush. Next part is, whoops, kick the camera. Next part is you're going to want to push this in just what I would say is a coon's hair amount. And I'm going to try to show you that here. There we go. You can see it's just barely kind of sticking in there. And the reason for that is so when we put this on, we can take the bearing side and then we kind of just tilt it into that. We tilt it into that pin. And then once you do that, you got to lift that end over. And there you go. Now you can take this pin. You can take this pin and push it in once you got it a little bit farther. Again, you take your servo horn. You got to trim that to spec pretty much. And I'm going to see if the camera will pick it up. There is, I don't know if the camera's going to pick it up. You pretty much have to trim it. You can kind of see there's an edge right there. And you're going to trim it around. You're going to trim it around that last outer ring that you can kind of see. And it's going to look like that. Of course, you're going to want to have your motors mounted to the bucket, the motor mount, whatever you want to call it, before you finish this up. And then you can push this pin in a little farther. Just figure out how much grip you need to get it back out. Pin doesn't have to go in there very far. Again, it is stabilizing everything. So yeah, and that is it, and that's how you assemble it. You're gonna want to have yourself a good hardware pack. Again, what I use is this. These are all my hardware packs. I get these off Amazon. I got an M3 kit. I got an M2 kit. Your Ace Hardware Menards washer kit. This is an M2.5 kit, which you will need on certain things. And then you're pretty much freaking covered. You will also, like most of us, have to extend these wires. These came off my Swordfish, which is why they're cut short. If you don't, you need to get some leads, solder those up, make them longer, add some heat shrink, and you have to account for the you're gonna have to account for the bending and of the motor bucket. So you gotta have enough to where it can tilt up, and not only tilt up but tilt back as well. That's also another huge one. So will that even be enough right there? Oh yeah, that'll be more than plenty. The ESCs are gonna sit right down here in this bucket. I've made them wide enough so you can run bigger ESCs and tall enough. And I believe that is pretty much the assembly of your nacelle. And here you go. This is our finished product. Don't mind these grind marks. Just something that I was messing around with and didn't need to do it. You will not need to do that. You can see the extra loom of wire that we do have here. This is when the nacelles are down, and then when these nacelles come up and even tilt all the way back, there you go. We still got a little bit extra. That's what the wiring looks like coming out. You could run your wiring through the same channel that the ESCs ran through. It just seemed like it was gonna bind it up. It seemed like there's just a lot of wiring going through there. So I chose not to do it. This seems to work great. Just use duct tape wrapped around, and of course the ESC and the wires coming out. Another thing about obviously having the longer pin, when you push this pin all the way in, and you're not gonna be able to see, you can kind of see that pin pushes on the servo body, which actually helps with this gap
right here. So that gap's too tight. The servo kind of binds up a little bit, and you just don't want that. And then there you can see the bearing right there. So piece of cake. Next we'll go into mounting it on the wing. Okay, moving on to mounting the nacelles on the wing. You're just going to need a couple bits of equipment here. We're going to need hot glue and E6000. You're also going to need a couple of skewer sticks. These are skewer sticks right here. You can get these at any, I'm assuming, grocery store or whatever. The skewer sticks go in and they actually just add as a support to lock in on the wing. The nice thing is the carbon spar, these are my skewer sticks. They just have black permanent marker on it. Your main spar goes right through there. So these things are probably not going to rip themselves off. And make sure you double check, like this one right here is my test. Just make sure when you push them through, if you push it in a weird angle and you can't get it to go through the bottom hole, do not worry about it. My previous Dolphin build, that was a twin motor and had tons of power. I didn't have a bottom hole in there. So if it makes it through, more power to you. And then just trim off the excess and that's it. What I did at first was I took hot glue and I took a bead of hot glue and I just went around the corner with hot glue, licked my finger, did the whole smear, put a little bit underneath the flap, but I did it around the top and the bottom. There's still some dirt on there. And on the bottom too as well. And I just did a little bit. I went ahead and flown this successfully and hovered it because I forgot to E6000 and the hot glue held just fine. So I don't recommend just using just hot glue. I just did E6000 on the top and pretty much kind of smeared it over the top here, and that's good. So I did on my my other twin, and the thing went like 150 mile an hour, wide open throttle, 100 amps, no problems whatsoever. We're going to flip this over now. So with this flipped over, you can see what I did for my nacelle is I slid my nacelles all the way over to where they're pretty much touching the corner of this little servo bump right there. I can still replace my servo if I need to. And that was just what I decided to go with. Just seemed like a good distance, and that's it. If you're off by a little bit, I'm telling you people, it's not that big of a deal, I don't think. The biggest thing is, I'll show you on this one, is that your blades don't touch the body. I mean, that's pretty much freaking it. You're also going to have to cut a channel in your wing to run all your wiring, because you're going to have, you know, 2 servo lead sets and your ESC wiring that's going to have to go through. I had to make a little notch here as well to get the wire to go through. And the hole that the wiring goes through, I had to make that bigger too as well. So everyone does their wiring a little bit different. That's how I did mine. Again, there is a left and a right. Let me grab my piece. Again, this contours this contours the wing. So when you put these on, obviously this should be facing out because there is a wrong way to do it. And let me see if I can get the wrong one on there. So see how that is going straight? If I mount it on this side, you can now see it's at an angle in. So you just have to watch out for that. It's not that big of a deal. And again, you can tell, put it on the wing, push it up tight, and slide it until where this is just about touching that dimple for the servo. And that's all there is to it, guys. There's not much else to it. Maybe you want to go farther out. Maybe you want to bring these in closer. My old Dolphin, let's flip this around. When I had this set up with just the twin motors, you can see my old holes. This is the exact same nacelle mount. I had them there. I just went a little bit farther out. I figured in hover mode, having them out a little bit farther will give it some roll stability. Don't know if that's going to work or not, but I mean, it does work. Didn't know, if that would be the right case. So do whatever you want to do. This is what I did, and it works. Okay, moving on to the back of the aircraft. This is pretty simple. This piece right here that I made, of course, this is just some electrical tape. I've taken two different components here and combined them. This is actually all one piece, and this is actually just my motor mount kit that I've had in previous videos. I just extended it. The biggest thing is that when you have these props, you don't want the prop to overhang on the body because it's technically would be blowing down on the body. And honestly, this is kind of wide too as well, but it seems to work. This might get revised into something thinner, or you might use something else. But the biggest thing is that this sticks out far enough back so that the prop is not hanging over the body. Also, it helps with the center of gravity because it's adding weight to the back and it's allowing the plane to have that center of gravity. So if you made this go back farther, then, you could do that and the battery wouldn't have to go in as far. This thing is, you're going to have a long, either a screwdriver or Allen head. The bottom ones are easy to get to, but I'll grab my driver here because I'm using just an Allen head. This goes all the way into about right there. And as you can see, it's about right there on the base. Wiring goes down through the hole just like before. I'm going to flip this over. And then comes through and uses the ESC. Puts the ESC right in here. All these 3D printed parts, you're going to see links. All these links will be down in the description below. Just wanted to give you guys a heads up. And then that's it. And then just 4 screws, mounts that onto there. And for this to work, you've got to have the upgraded motor mount. Now, this comes with Atomrc now. They listened and then they included this. This gets glued in and provides a nice attachment point for this. It'll use all these mounts. Before, they just had this little piece of wood that was glued on here and was not very good. And you just can't do that. There'll be too much leverage. It will probably rip it off. But if you take this piece and you get it glued in there like so, that'll work perfect. So that covers the rear motor, the 2 nacelles up in the front. Now we'll move on to the electronics. All right, so here's my rat's nest of wiring. As you can see, I'm using the stock Atomrc F405 Navi. Totally works. This is the same flight controller that comes with the Dolphin, comes with the Swordfish, the Penguin, and it totally works for a VTOL. The problem is, it only works for the Dolphin VTOL. That's because the Dolphin is a fixed wing, and there's only enough available servo outputs for just the fixed wing part of it. If you have a tail like the Dolphin, you will not be able to use it because you just won't have enough outputs on the flight controller. And I'll explain all that and explain more in the programming video. So how I have mine set up, this is my rear, and then this is from that wing, and this is from that wing. I decided to mount my flight controller right here towards the center of gravity. Now, I 3D printed this piece that I found online. Of course, I'll have a link for that in the description. It only works with the F405. I don't have the Matex, so maybe it does, maybe it doesn't. And then it just kind of sits on that platform and is hot glued underneath. Just looks nice. You could also use the factory plate that comes with it. It's whatever you want to do. You will have an open port right here. And that open port, as you can see how this is set up, motor. These are my elevons, tilt rotor. That's what I mean, tilt rotor. And that's it. Fortunately, the way this is set up with how they group stuff with the VTOL, I can't use that. So I can't even use my pan. It is now just a fixed camera on the front until I upgrade this, which I probably will. Nice thing is, you know what? It came with the flight controller. We can use it. Now, the next thing you're probably wondering is, Jeff, well, there's only 2 ESC outs on here. How do you have 3? To do a VTOL, you don't have to have 3 outputs for 3 different ESC controls. You can wire them all up to one or whatever you want to do. Obviously, the more pads you have, the less current's going through it. So what I'm going to do on mine is I'm going to have this one going to one wing, this one's going to the other. And then I'm just going to take a ground I'm going to take a power from this pad, and I'm going to use the ground from this pad. These pads are all connected. I mean, they're all connected. Like if you were to run a continuity test between these, all the powers are connected and all the grounds are connected. It is the ESCs on the plane that control the power to the motors. So just wanted to share that little tidbit. Now, so that is pretty much it in a nutshell. Again, you can totally use it on a fixed wing. You will just completely run out of outputs, and this is all you can do. So you don't have an extra output for anything else. I just mount my USB data link connector here in the back so it's out of the way. Just put on a little 90-degree bend. Makes that easy. I have the GPS mounted out here just because there's so much wiring going on in here. I just figured maybe it would help with GPS lock quicker. These are just my leads for my LEDs that are underneath. I kind of just have them off right now. I'm trying to just get an idea what the amp draw is going to be on this board. I'm not trying to overload it. And actually, these LEDs do use they do have a little bit of an amp draw. So just trying to keep things light. So that is pretty much it. And I'll pull off the top here. I just got a little switch here for my VTX. Makes it easy to, once satellite lock gets, I can just turn it on. I mount my ELRS receiver up there. Another thing you might want to think about, and this is kind of a little bit overkill, and maybe this won't be so bad, it's just cooling. This ram air scoop works really well, keeping everything cool. Air in, air out. You know, the batteries can get hot, and so I'm just trying to keep the thing cool to make everything last and not overheat. So this is what I did. It's maybe a little overkill. This was from when I was on 6S. And I think that is it. I don't think I'm missing anything. Okay, I did forget something. Battery. Your battery is going to want to fit. If you're running this configuration, you're going to have to get this battery to get sucked back underneath there like so. There you can see it on the board. If you don't do this and you only run it up as far as this thing will normally sit, if you only run it up to like right there, you are going to have to add weight to the back of this. And you don't want to have to add any weight. You just need to come in here with a soldering iron, and I'll get my light here so you can see well. You're going to want to come in here with a soldering iron, and you're going to want to remove some of this foam material. And it is fine. It ain't going to do nothing. It's going to have plenty of stability. I've had this plane over 160 mile an hour, and that's it. Now, you're going to see I have these little plastic pieces in here. Come on, camera focus. These are because I actually wallered this thing out massively to fit a 6S battery in there. So I just had to put those back in to hold the battery well. But by doing this gets the battery back farther and center of gravity, and the plane will be so much more happier, and it just sits in there like that. I use this little piece of foam right here with my battery strap, and I kind of just strap that in to just kind of keep everything held together. This is the foam that came with the packing too. Just kind of cut it up. Then speaking of battery, I'm using a lithium-ion battery. This is an Upgrade Dark Energy. Your aircraft is going to pull 30 amps in takeoff mode. When you take off, it's going to pull 30 amps. These batteries can do 20 amps continuously, and this thing can burst 40 amps for 10 seconds. So that gives you a pretty good window. This is a 4S 5000 milliamp battery, same as that ZOHD, same size in fact, except it's just got a higher output to it. They also make this in the dark energy in the red version. It's a 4500 pack, and it can do 30 amps continuously and burst 50, which I'm probably going to look into that too, honestly. And weighs, I think, the exact same as this, or maybe even a coon's hair less. So you can go with, and you can go with the LiPo. Of course, the LiPo is going to be heavier than the lithium ion, and it's going to have less energy. So things to keep in mind. Links in the description. So now you know what it takes to build everything, what you need to print, how you need to assemble it. And I think that's going to end it for this video. Video 2 will be on the Inav programming side, and I will be able to completely explain this to you now that I have learned it. And we'll see you in the next video. All right. Well, thanks for watching. Any questions, look them up. All the links for everything will be down in the description from all the Thingiverse stuff and everything else. Thanks for watching, everyone. Bye.